Hi everyone, in this video we will be modeling a step bar in the Ansys, and you can see the question on the screen. So let's get started. At first we need to select the static structural, click and drag it here. Open the engineering data, right click and click on edit. Here you can see we already have a material of a structural steel, and in the question we are asked to apply a Young's modulus of 2 into 10 to the power 5 Newton per millimeter square. If we convert it to the Pascal, because as we know that 10 to the power 6 Newton per millimeter square is equal to 1 Pascal, we will get in this value 2 into 10 to the power 11 Pascal. So here we don't need to make any changes. Then go to project tab, under geometry right click and select new design modular geometry. Here you can see 3 planes. We will be using XY plane. Right click and look at. Now we will model our geometry step bar. So for that we need to, but before that we need to select our unit to millimeter. Then go to stretching, circle, and here we will create a circle with a diameter. To change this diameter, go to dimension, under general we need a diameter of 15 mm. Let's zoom out. It should be 15 mm. Now click on generate. Now we have to extrude it. Under extrude, in the geometry click apply, and under depth we need 180 mm of depth. Click on generate, and here we have a length of 180 mm. Okay, so now we will create a plane, and we will give our plane our offset in the Z direction. Of 180 mm offset. So this way we can bring this plane from here to here. Click on generate. Now click in the Z direction, and we need another circle. Now follow the similar step. Go to stretching, circle, and under dimension general we will specify it dimension. We need a dimension of 10 mm. Click on generate, and then extrude, apply the geometry, and we need a depth of 200 mm this time, and then click on generate. So we are done with our geometry. Now let's close it and model it. Under model right click and edit. Now we will be moving with our machine. So we are under model. go to mesh and select on generate mesh. So our mesh is generated. We can also refine our mesh. For that we need to right click on mesh, insert, and click on refinement, and here we need to select our geometry, and our geometry has 5 faces. To select all those 5 faces, this part, just hold the control key, and the last one is this. Okay, now apply geometry, apply, and here it shows 5 faces. Then in the refinement we will go for 3 finest one, then update. We can even update, we can update from here. So it is updated. Now we will be adding our boundary condition. For that we need to close this one, right click, setup, and edit. So here in the environment tab we can add our boundary conditions. So click on fits, and this face is fits. To select this face, click on this face and select the face and then apply. So our this part is fixed. Now we will apply a force in this face in the -z direction. So for that click on force. Now select the geometry and apply geometry. Under type we need a force. Okay, under defined by we need a component, not a vector, component, and we will apply our force in the z direction, -z. Minus, we will be applying a force of 5000 Newton. Force is applied. Now we will apply a force on the other end. Click on force and then select the geometry, apply geometry, and under defined by select the components in the z direction. Give a -z direction of 2000. Okay, now we will click on static structure, and we can see that the boundary structure is defined. A is fit support, B with a force of 5000 Newton, and C with a force of 2000 Newton, all in the -z direction. So now we will solve it. Insert, on the solution right click, insert, deformation, and we need a total deformation. We also need a directional deformation. Right click on solution, deformation, directional, and select the, since we need to find the deformation at the node point, we can select the face. Since the deformation of the face at the nodal point is same as that of the nodal, then under geometry click apply. We need another one. Right click on solution, insert, under deformation click directional, and now we will select the another one. Under geometry apply, Now we will solve it. Right click and click on solve. So it is solved. Now we can see the total deformation. So this is the total deformation. Here is the maximum at the end point and minimum in the face. We can even animate it. Yeah, we can see the animation, but our problem asked us to see the nodal displacement at point B and C. So for that we will click on the direction deformation, and this is the displacement and deformation at nodal point B. We can also animate it, so we can see, we can even export this in the text. Okay. Now let's view this at C. Click on here, and this is the deformation at the node C. We can even animate it too. So this way we have solved our problem, and thank you for giving us this assignment. We have learned a lot. Thank you. And by the way, this problem can be also be solved in the Python and MATLAB. So we will be solving